Hello guys, welcome back to the universe of TechUp. In this tutorial, we will learn about traversal in graphs. There are two types of traversal in graphs. First one is BFS and second one is DFS. BFS means breadth first search and DFS is depth first search. First, we will understand what is BFS. BFS means breadth first search is a network search method that starts at the root node and explores all surrounding nodes. It's also known as a level order traversal. Level node traversal. It is a graph traversal algorithm that explores the nodes level by level, starting from a given source node. It visits all neighboring nodes at the current depth or level. Before moving on to the nodes at the next depth level, BFS is commonly used for traversing or searching tree or graph data structure. BFS is a breadth first search. Find the shortest path using the queue data structure. In BFS, we are using a queue data structures. It is used to find the shortest path. BFS is a breadth first search is a graph traversal algorithm that explores the nodes level by level. Starting from a given source node, it visits all the neighboring nodes at the current depth or level before moving on to the nodes at the next depth level. BFS is commonly used for traversing or searching tree or graph data structure. Next, we move to the when to use BFS. When we need to use the BFS traversal algorithm. For example, in shortest path in unweighted graphs, we are using a BFS. BFS is ideal for finding the shortest path in unweighted graphs because it explores all the nodes at the current level before moving a deeper. And another one is level order traversal. BFS is perfect for level order traversal of trees or graphs, visiting all the nodes at the same depth. Next one is shallow or wide graphs. BFS works well on shallow but wide graphs as it explores level by level and efficiently handles many nodes at a given depth. Next one is minimum moves or steps. Problems like finding the minimum number of moves, like puzzles, like word ladder, are better solved with BFS. Next, we move to the difference between BFS and DFS. What are the difference between BFS and DFS? In traversal method, BFS explores all the neighbors at the current level before moving to the next level. Coming into the DFS, explores as deep as possible along one branch before backtracking. This is what DFS. Next, in data structure, we are used in BFS or queue, FIFO method. In DFS, we are using a stack, LIFO method or recursion stack. Next, it is the best for finding the shortest path in an unweighted graph. BFS is used to finding the shortest path in an unweighted graph. And DFS is used to exploring all the possible paths or solving a puzzles like a mazes. And use cases for BFS are shortest path in unweighted graphs like social networks and web crawlers like that. And DFS use cases for solving a maze or a puzzle problem, detecting a cycles in graphs, topological sorting like the DFS are also used in like and BFS used in the level order traversal of tree. In performance on deep graphs may require more memory in BFS. Coming into the performance, it requires more memory. Why deep graphs as the queue holds many nodes. And coming into the performance, DFS is efficient for deep graphs as it travels a single path at a time. And performance of wide graphs is efficient for shallow wide graphs as it processes all level by level in BFS. Coming into the DFS, may require more memory for wide graphs as the recursion stack can grow large. It is BFS is used for finding the shortest path in a unweighted graphs. DFS is used not guaranteed to find the shortest path but explores all the paths. DFS is not suitable for weighted graphs, but the DFS are not suitable for weighted graphs. Rickshaws or Bellman Ford should be used. In graph representation of BFS can be used with both adjacency list and matrices. Coming to the DFS can be used with both adjacency list and matrices. In the tree traversal, use it for level order for traversal in trees using a BFS. In coming into the DFS, use it for pre-order, post-order or in-order traversal in trees. In BFS, no backtracking. In DFS, uses a backtracking to explore new branches. The algorithm type we used in the BFS are greedy approach, explores level by level. In the DFS, we are using algorithm type backtracking approach, explores the depth first. Example of BFS are finding the shortest path from a source to all nodes in an unweighted graphs. And example for DFS is exploring the all possible paths to solve a maze problem. This is all about difference between BFS and DFS. You got it right. Next, we move on to the applications. In BFS application, finding the shortest path in a unweighted graphs. We are using a BFS in finding the shortest path in unweighted graphs and using a level order traversal in trees and also used in web crawling and also used in social network analysis, finding the shortest path between users like that, and also finding a nodes at a specific level in a graph or a tree and minimum moves in a game or puzzles and also used in friend suggestion algorithms in social networks and finding the shortest path in a maze and level by level exploration in AI game also. Next we move on to the algorithm part. What algorithm says is first we need to initialization set the status of each node to 1 ready state. Initialize an empty queue. Next, enqueue the start node. Push the starting node A into the queue and set its status to waiting state and repeat until queue is empty. DQA node N from the front of the queue. Process node N and set its status to 3. Proceed state. Enqueue all the unvisited neighbors of N status is equals to 1 and set their status to 2. Waiting state. This is the algorithm for BFS. This is the algorithm for BFS. Next we move on to the one example to show how BFS works. In breadth first search, a queue is used to manage the order in which nodes are explored. Unlike depth first search, which uses a stack for backtracking and explores the nodes neighbors as deeply as possible first. BFS explores a graph level by level. This means it visits all the neighbors of a node before moving on to their neighbors. It explores all the nodes at the current level before proceeding to the next level. This is the what what is the BFS? And key concept of BFS with QR. In BFS, the queue helps keep track of nodes that need to be visited. It follows a first in, first out order, meaning that the first node added to the queue in the first one to be proceed. BFS algorithm says start from the source node, enqueue the starting node to the queue, mark it as visited to avoid reprocessing it, and explores the nodes level by level. DQA node, this is the node being explored. Visit the node, process it. Then enqueue all its unvisited neighbors into the queue, marking them as visited. This is the algorithm for BFS. And BFS steps, let's explain BFS on a grass. This is the visualization of breadth first search. What it says first, this is the example of graph. We are performing a breadth first search traversal. First, we need to start from the A. mark and NQA. NQ means insert into the queue. In queue, insert means NQ and delete means DQ. Mark and NQA to this queue. Next, we need to DQ the A. Why we need to DQ? A adjacent nodes are E and C. So, we need to DQ a node A. Next, we need to process the next node, that is C. We need to visit C. After A, we need to visit C. Visit A, process it. Next we need to visit C. Then we need to DQ the C. First we need to visit the A neighbors are C and E. First we need to visit C. Next we need to E until the neighbors are visited. Next we need to visit E. Next we need to DQ the C. Then we need to mark and NQ the B. So the C neighbors are D and B and F. So we need to take B. Mark and NQ the B. And next mark and NQ the D. Then mark and NQ the F. Because these are all the unvisited nodes of C. So we need to first traversal in B. Next we need to traverse D. Next we need to traverse F. Then we need to DQE because all nodes are visited. So we need to DQ from the E and also DQ the B. So in B nodes, adjacent nodes are C, F. So all nodes are visited. So DQ from the B. Next we need to DQ from the DQ B. Next we need to DQ D. Why we need to DQD? Because all adjacent nodes are visited. F and C are the adjacent nodes of C, D. So we are DQ the D. Next we move on to the DQ the F. F adjacent nodes are D, B and E are the adjacent nodes. So we are all visited the nodes. So DQ the F. Next complete the breadth first search graph. This is the complete the breadth first search graph. This is all about breadth first search. Next I am taking one example to show how breadth first search works in using a Python programming implementation. I am taking one example to implement a Python programming language using a Python programming language. First, we need to, in BFS, first we need to import the queues. In BFS, we need to use the queues. Explores the vertices of a graphs layer by layer. So that we need to use queues in BFS. First, we need to import the queues from collections. Import D. Next, I need to BFS requires a queue to manage the nodes as they are visited. So that I need to import the queues. Next, I need to define BFS. BFS to define BFS for graph, comma, start node. The parameter graph and start node as the parameter. Graph represents the connection between nodes using a adjacency list. And start node, the node from where BFS starts. This function is reusable for any graph and any starting nodes. Next, I need to initialize a queue for BFS. Q is equals to DQ. Add the starting node to the queue. Q is equal Q dot append start node. Keep track of visited nodes. Next step is keep track of visited node. The visited is equals to set Why we need to use this is visited keeps track of nodes that have already been explored to avoid the infinite loops in cyclic graphs and prevent the redundant visits the same node. Start node is added immediately since is it first node we explore. Visited set next visited dot add start node. Start node is added to immediately to visited so that we add the start node. Next, I write the code for BFS traversal. I'm using a queue queue queue. Why this loop runs until the queue is empty. So that why we need to use while loop. Because as long as there are nodes in the queue, BFS continues processing them one by one. Next, I need to current node equal to queue dot pop left. Being BFS is process the nodes in the order they were added to the queue order. And next one is pop left. It is used to remove and return the front node for processing. This is equivalent to visiting the node. Next, I need to print the current node. Current node, comma, end is equals to space. This line processes or visits the node. Here, it is a simply prints the node to demonstrate the traversal order. Next, I need to write the code for visit visit all the neighbors of the current node. So this code tell visits all the neighbors for the current node. For neighbor in graph current node. Node is connected to other node like neighbors. To explore all reachable parts of the graph, the algorithm iterate over the neighbors of the current node. So that is the reason we need to use for loop for neighbor in graph current node. Next, if neighbor not in visited, if neighbor not in visited to why we need to this line means it to prevent revisiting the nodes, which can lead to infinite loops in cycle graphs like that. BFS checks if the neighbor has already been visited or not. Next, mark the neighbor as visited and enqueue it. I'm writing the code to mark the neighbor and as visited enqueue it. Visited dot add neighbor dot append neighbor. This line tells visited dot add neighbor marks the neighbor as visited to avoid reprocessing it later. Next, queue dot append means append neighbor is adds the neighbor to the queue. So it can be processed in the next layer of the BFS. Next, we move on to the representing the graphs as an adjacency list. Equals to representing a adjacency list, we are using a curly brackets. A the A adjacents are B and C, right? Next, B adjacency are E, D and next, the C adjacency are F. Next, D adjacency are empty, right? Next, E adjacency are, if is the adjacency of E. Next, F adjacency are empty. F I take. Next, I need to write print. Print BFS traversal. BFS traversal FS. BFS function, BFS of graph, comma, start node is A. The graph representation. What the BFS logic is, add the starting node to the queue and mark it as visited. While the queue is not empty, dequeue the front end and process the node, in this case print it, and enqueue all the unvisited neighbors of the current node. This is the BFS logic. I need to run this code. The BFS traversal is, first it visits A, next it visits B, and next is it visits C, and next it visits D, and next it visits E and F. This is the BFS traversal. This demonstrates as layer by layer. First, we need to initialize a queue. A dequeue is used to implement the queue for BFS. Next is used to visited set. Keep track of visited nodes to prevent revising and entering the infinite loops. Next, we need to implement BFS logic. Add the starting node to the queue and mark it as visited, and while the queue is not empty, dequeue the front end. The process the node, in this case print it. Enqueue all the unvisited neighbors of the correct node. This is the how BFS works. If you like this video, please don't forget to subscribe, like and share and comment in this video.